Now I'm going to talk about Newton's laws of motion. Newton's laws of motion. Now the laws are broken down into 1, 2, 3. Now the first law is known as the law of inertia. Law of inertia. Now I'm going to break this law down for you to understand. Now in this law, it is normal to take note that a body, this body is at rest. Is this body moving? No, it's not moving. Is it moving? No. So as far as this body is at rest, it will remain at rest. A body at rest will remain at rest. While a body in motion will remain in motion unless it is affected by an external force. So another force has to come in. Just like we have friction. Friction comes in and stops that car from moving. You apply the brakes. When you apply the brakes, the car stops immediately. When you press stop in that your blender, it stops moving. So that blender will continue to rotate, continue to work until you apply a force. And that force will stop it from moving. So this says that a body at rest will remain at rest, comma, a body in motion will remain in motion unless it is affected by an external force. So you don't expect someone or a machine that you have powered, you have to stop working, work, do this and that. You expect the machine to just stop working like that without you applying an external force to the machine. No, it won't stop. It will continue to work until you have told the machine stop. Just press the button and the machine stops working. So if you don't apply an external force to that body, the body will not stop. So that external force can be what? Friction. That friction can be in form of the what? The brakes. When you apply the brakes, the machine will definitely what? Stop. So we have the second rule. Now this second rule, we can just write it as A equal to F over M. So this is trying to say that the acceleration is directly proportional to the force and inversely proportional to the what? The mass. The acceleration is directly proportional to the what? Force and inversely proportional to the mass. And from here we can cross multiply to say force is equal to mass times acceleration. So this M here represents mass times acceleration. So we have that force is equal to mass times acceleration. That's just the second law. Force is equal to mass times acceleration. Then we have the last one, which says for every action, there is an equal and opposite reaction. So the third law says for every action there is an equal and opposite reaction. So meaning that if the weight is acting downwards, the reaction will be acting where? Upwards. So if the weight is acting downwards, because weight usually acts downwards, definitely the reaction will be acting where? Upwards. So take note, if the weight is acting downwards, then the reaction will be acting where? Upwards. So take note, the reaction is like an opposition to the weight. the reaction is like an opposition to the weight, while friction is an opposition to force.